I'm Maggie Beestra, and I'm graduating in May of 2015. I did research this summer in the Department of Earth and Planetary Sciences under Professor Jeffrey Catalano. I'm majoring in environmental earth science in the Earth and Planetary Science Department as part of the College of Arts and Sciences. Plants and soil systems would not be what they are without the presence of organic acids and iron oxides. So iron oxides are basically just like rust, and organic acids are excreted from plant roots into the soil system. And so iron oxides and organic acids have some complicated interactions in the soil system. But something really interesting that happens is iron oxides, they can have ions and compounds such as contaminants, they can attach to it, and then the iron oxides can then take those contaminants outside of the system because they're attached. This is really important because it can take those contaminants out of groundwater, and it can also help to maintain the fertility of the soil system. So in my own research, I was looking at the interaction of the iron oxide goethite with the organic acids ascorbate, which is just vitamin C, and oxalate. And I was looking to see if the presence of those organic acids affected goethite's uptake of the metal zinc. And zinc is interesting because in small quantities it's considered a micronutrient, but in larger quantities it's a contaminant. So the soil system has to balance the amount of zinc present. So what I did is I made 5 sets of samples, and in each set of samples I had a set amount of goethite. And then I put either oxalate or ascorbate so I could compare the two different organic acids and how they influence the goethite. I also put varying quantities of zinc into each sample, and I knew how much zinc I was putting in so that later on I could compare it to the final amount of zinc present. I also adjusted pH to see if that had any effect. So using those samples, I let them process, and then I went to the engineering school and used the Nano Research Facility. There I used an instrument called the ICP-OES, and using that instrument I got the final concentration of zinc present in each of the samples. And so since I knew the initial concentration of zinc and the final, from the difference I could figure out how much zinc had been taken up by the goethite. And then I could compare those numbers if there was oxalate or ascorbate present, and then I could also compare that to pH. So we learned that the system is much more complicated than we expected. We did see differences between oxalate and ascorbate, how much zinc was taken up by the goethite, based upon which organic acid was present, as well as pH. We also noticed that the ascorbate is complicated because it's very oxygen sensitive in the system. So that's something that needs to be explored further in the future. We also want to further explore the interaction between ascorbate and oxalate, and see how those impact iron oxides.